Good morning, my name is Abigail Shear, and this video will be for my online class for Natural Science Education 321 for the University of Wisconsin-Superior. This video explains my micro-teaching project and the lesson that I created for that. So the format for this video is going to be the reason that I chose to teach this lesson. And then I'm going to talk a little bit about the lesson, and then I'm going to talk through how I incorporated different subject areas throughout this micro-teaching project lesson. And lastly, I'm going to touch on the 5 E's and how I incorporated those throughout my lesson. So to start, I am going to just explain my reasoning behind why I chose to teach this lesson. So the lesson that I created is for a first, it could even be taught in a second grade class. And the reasoning behind that was I actually taught a very similar lesson in a 4K classroom, and the kids just had so much fun with it. So my lesson is basically teaching students about motion and the gravitational pull. And when I did this in a 4K classroom, I set up ramps, and I had on an elevated surface. And I had various objects that the students took turns sending down the ramp. And it was very less in depth when I did it in the 4K class. So the students, we just said which one do you think will go faster, and why do you think that is? And so it was just kind of basic. So I had done that in a 4K classroom, and the kids really enjoyed it. They were sending it down and making hypotheses and guessing, I don't know, I think this will go faster. And obviously they didn't have very concrete reasoning or documentation or anything, but it was just a really fun lesson. So when this micro-teaching project opportunity came up, I thought, oh, that would be fun to incorporate this into a little older age group and explore options for a little more in depth, and because obviously students who are older can grasp those things. So I'm going to talk more specifically now about my lesson. So I created this for a first to second grade classroom. I said that there's 21 students, and I said it's kind of for physical science, and the theme is motion and matter. So when I created this lesson, I thought it would be fun to have it be the launch for multiple lessons on exploring motion and gravity, and then eventually moving into pushing and pulling objects and how that affects the motion. So this is the first unit of, I said 3, I think. And I said it would take about an hour. So the big concept of this lesson is having the students be able to identify how the size, shape, and weight of an object affect how it moves down a ramp or elevated surface, and then answering the questions why does it move the fastest? Why does it move slow? So my objectives for this lesson, I have 4 of them, and they are: student will be able to identify the size, shape, and weight of an object and how that affects the movement down a ramp or elevated surface. So kind of the main theme of the lesson. And then my second objective is students will make predictions of what objects will reach the end of the ramp quickest, carry out their predictions, and record their findings to better their future hypotheses. Third objective is students will effectively communicate with their peers to build on each other's ideas as they explore and hypothesize together. And my fourth objective is students will draw their findings with the class, students will draw their finding with the class through picking an object and drawing a picture about it. They will include details of the object in their drawing, size and shape of the object. So then I explore or explain like how I will communicate these objectives to my students. And then I created a rubric, basically just built exactly off those objectives, and I included like a few numbers, like the students will make at least 2 predictions and they'll record this to better their hypotheses. They'll communicate effectively like 90% of the time. So I use the exact same objectives, I just tied in numbers to make it measurable. So I did that in a rubric for my expectations for the students' learning. So I have 4 sections in that. And then I'm going to talk about, I have multiple standards. Next Generation Standard, WMASS Standard, Common Core for Literacy and Math, and then Art and Design Education Standard. So now I'm going to just dive into like what my lesson would look like if I was teaching it. I wish I could actually teach it. That would be a lot more engaging. So to start out my lesson, I am going to be like, good morning, first graders, and to engage them, I would hold up like 2 objects for them. So like say a Lego and a marble, and I would say, can you tell me about these objects? And I would have the students like identify characteristics of the objects, like if they think it's heavy or light, the shape of it, and how big is it. So we would like talk about those things together, and I would kind of be like scaffolding and modeling for them how to find those details. So we would talk about the details of each of those items, and then I would ask like, my friends, what do you think would happen if I sent these 2 objects down a ramp like this? And I would like show them the ramp, and then I would have them make guesses, and I would explain that a hypothesis is a prediction or a guess on the details or object that they have. So making like a educational guess or whatever. Sorry, that's a poor example. But so I would have those objects, and then they make hypothesis, and we would kind of talk about like why they think a certain one would go faster or why it would go slower. So then we would actually test that out and send them down the ramps. And then we would talk a little about like, oh, did our hypothesis come true? Why do you think it didn't? So that would kind of be like the launch into the lesson. And then I'm going to talk about the explore session. So that's the launch. And then after that, it's kind of a long session of like explaining to them how I want them to be recording their findings into a science notebook or a journal. So basically I explained to them that, and I'm recording all of this onto a whiteboard as I'm explaining it, so they have like the verbal as well as the written, so they can refer back to that as needed. So I'm going to talk about how I will break them into small groups. So there will be 7 groups of kids, and 3 kids in each group. And they'll each have a ramp and multiple objects to be testing out. So basically what I tell the students is that they're going to pick an object, and they're going to get their science journal, and they're going to document all of the details of the item that they've selected. So say if it's a Lego piece, they're going to put it on a scale and find the weight of it and record that. Then they're going to say like it's a rectangle or it's a square. And they're going to measure. I'll have a ruler for each student actually. And then they're going to measure it and say like it's 1 inch, 1 inch is high and 1 inch wide. And then so they have the weight and the size, rectangle or square, and then the shape, the rectangular square, and then the size by using the ruler. So they're going to document all that, and then I'm going to have them come up with a hypothesis. What do they think is going to happen when they send that down? So then they'll record that, and then I'm actually going to have them test it out. So they're going to do that, and I have them each testing out and documenting on 2 items. So they're recording all their findings. So they're going to develop that hypothesis, record all those details, then they're going to test their hypothesis, and then they are going to have a stopwatch, and their friends will help each other in that group to time how fast it actually went. Did it slide? Did it roll? Did it kind of just jolt a little bit, or what happened when it went down? So then they'll record their findings. Did it match their hypothesis? Was it way different? And then why did they think that happened? So I'm going to have them do that with 2 items. And they all have a science journal. I have a whole extensive list of all the materials that would be provided. Let me just read those off to you. So I have just the items that they could choose from. They can pick any 2 items. It's not like they're assigned or anything. So the items that I would have would be a feather, a marble, a block, a bouncy ball, a Lego, a plastic animal, metal car, a crayon, a sponge piece, a stick or wooden pieces, a rock, and then obviously the ramp. So I picked those because there's some natural items there, and then things that they play with and that are in their classroom, so that they would just be able to explore, and obviously objects of differing sizes and shapes and weights too. So those are the items that the students would be able to choose from to send down their ramp. So then I have them explore that for 20 or 30 minutes, just testing those out, and then I tell them after you do your 2 and record those, then you can explore any of them, and you can raise the ramp a little bit and see if that affects the speed. You can lower the ramp. So basically I give them ideas of how they can explore in different ways, but then I open it up to them to be able to explore however they want. And I'm there to provide scaffolding and support, and I write in my lesson plan, be walking around or asking questions to prompt further inquiries. So that's that section of that. Most of it is just them exploring. So I let them again do that for 25-30 minutes. And then I have them kind of stop, and I have them just rewind. So before they even explore, I tell them be sharing what you're finding with your friends, and so hopefully to provide that rich communication and exchange of conversation, oh Joey, the Lego went really slow compared to the rock, or just I wonder why that is. So to have them engage in those conversations. But then after the exploration, I kind of pause, and then I say I want you to talk with your friends. What happened when you were exploring? What surprised you the most, or did your hypothesis come true most of the time or not? Why do you think that happened? So then I give them 3 to 5 minutes to talk in their small groups and just share with their friends oh, when I was doing this happened. And so just kind of to provide that opportunity for them to be talking and engaging. And obviously I'd have a lot of fun walking around and listening to what they were saying and taking notes, and just seeing if they were grasping how the size, shape, and weight of an object affects its speed. And after that, I would kind of wrap up the lesson through having the students through having them draw. So then after they talk about it, I say, like, go to your writer's workshop, and we're going to draw a picture about your findings. And I explain every step of the way, so there's no surprises. And I also, like, document on the board, like, in bullet points of what they should be doing. And so basically, like, the closure of the lesson is having them draw a picture of any item. I want it to be different from their science journal, though. So I have them draw a picture of an item, and what I want them to include, like, I want to be able to tell what the item or object is in the picture. So if they draw a picture of, like, a rock going down the ramp, I want to be able to tell that it's a rock. And obviously they're in first grade, so if they have to explain that to me, that's totally fine. So I have them draw a picture about that and include the details, and then I have them say, like, explain what happened when they sent that down. Did that match with their hypothesis? So then I'm just providing another way for them to communicate what they've learned through a picture format, and then they include some writing in that too. And then I also have them include a question that they have, just to engage in later in our unit. So the reason I did that was because I wanted to take their questions and then turn those into learning opportunities to elaborate on what we've learned. And if they wonder, like, what would happen if I push the car really hard down the ramp? Well, we'll explore that tomorrow. Like, so taking their questions and their inquiries and turning those into rich learning opportunities was my heart behind that. And then that basically ends my lesson. I just have them turn in their pictures and then meet me out the carpet. And then, so that is just a quick, brief, jumbled, hopefully, explanation of my lesson. Now I'm going to talk about the different subject areas that I incorporated through my lesson. So first I have math. I did that through them timing the object, how fast it was going, through measuring the object, and using a ruler. And then I have art. They are drawing a picture and explaining their picture through writing. So I have writing in there too. So my main, obviously, my main subject is science, and then I have the math and writing and art. And they have writing when they're documenting in their science journal as well. So those were the other subject areas that I chose to touch on throughout this lesson. And lastly, I kind of talked about this when I described my lesson plan, but I want to touch on how I incorporated the 5 E's into my lesson plan. So first, engaging. I did that through, like, the launch into my lesson. I did that by, trying to pull up my lesson plan. So I did that through, like, the beginning, asking what would happen, like, what would happen if I sent this Lego piece down the ramp? So just, like, getting them curious and wondering what's going to happen. And then for the explore session, I provide a lot of time for them to explore with the different objects, and testing their hypothesis, and just exploring with their friends different objects and how the, again, weight, size, and shape of an object affects how quickly it moves. So a big portion of my lesson is the explore, and I did that on purpose because I wanted my students to be able to work on hands-on with the materials and be able to be learning and engaging and asking questions, and I would be there to provide support, obviously, as they're exploring. And then for the explain, I have them do that through they do that actually through their journal, they explain like what happened, why they think that happened. I have them do that through their conversations with their peers, explaining what happened, what stuck out to them, what was special or exciting, why they think things happened, and then also in their picture. So they're explaining in different ways. And then elaborate, I kind of touch on that through after they document the first 2 items, and then I encourage them, like, lift up the ramp, see what happens, like basically like opening the doors for them and like providing ideas, but like how could you change up the height of the ramp, what would that do, like just having them elaborate. And that way, and then also another way in which I chose to elaborate was having them come up with the questions that they still had at the end that we would be able to further explore later in the unit, and turn their questions and elaborate on those in the lessons to come. And lastly, the ways that I can evaluate my students through this lesson is through their science journal, through their picture, and through just my observations and my notes that I would take of them exploring and as they're having those discussions with their peers. So those are 3 different ways that I would be evaluating my students. So that is my lesson, and it would obviously be a lot more fun if I could teach this and show you how all of this exploration and exploring, that's the same thing, the exploring and elaborating and how all that would actually look like in real life. So thank you for listening to this long video, and I hope it was informative and helpful, and I hope you have a fabulous day. Thank you.